Okay, good afternoon. Today we will continue our discussion about the fluid static. Last time we have already discussed about the concept of fluid static. Maybe I'll try to review again what we have discussed last week. So the concept of hydrostatic pressure in static fluid is the hydrostatic pressure is the pressure caused by the fluid in static condition, and it's only influenced by the density of the fluid, gravity, and then the depth or height of the fluid. It means if you have, for example, A and B, this is the two location. If the location of these 2 points is similar, the depth of these 2 points is similar, you can calculate the depth from the baseline, for example, from the surface of the water. So the height is the same. And if you try to travel from point A, for example, to point B, the fluid is the same. This is only water, right? So the pressure at point A will be the same as point B. The same case is with point C, D, E, F, and G. But if you travel, if you compare with H, pressure at point H, since the depth of point H is different, it's higher than previous depth, then pressure at H will not be the same as pressure at G. How about H? Sorry, this is I. I'm sorry, I. This is. How about the H? If you compare point H and point I, the depth is the same, right? This is the depth. I noted it C. So the distance or the depth from the surface to these 2 points is the same. But if you travel from point H to point I, it will goes to the mercury and then water. So the fluid is different. Even though the height or the depth of the point is the same, but if you travel between these 2 points, the travel will follow 2 different types of fluid or more. I mean, it's not the same fluids, then the pressure will not be the same. Ya, jadi itu konsep tekanan hidrostatik. Tekanan di dua titik itu akan sama kalau 2 syarat terpenuhi. Syarat pertama adalah kedalamannya atau ketinggian 2 titik tadi sama. Cara menghitung kedalaman atau ketinggian, Anda bikin garis horizontal sebagai baseline. Di atas boleh, di bawah boleh. Ya, syarat pertama ketinggiannya atau kedalamannya sama. Yang kedua adalah kalau 2 titik tadi Anda selusuri ya, Anda berjalan melalui 2 titik tadi, fluida yang dilewati itu harus satu fluida saja, fluida yang sama. Jadi tadi misalnya A ke B itu lewat air saja, B ke C juga lewat air saja, ini sama. Tapi begitu H ke I atau I ke H, karena dia melewati air dan raksa, tekanan hidrostatik pada kedua titik tadi berbeda. So both need to be satisfied. The height or the depth of these 2 points should be similar. And then when you travel from one point to another, you just follow one type of fluids. If you got 2 different types or more, then the pressure between those 2 points will not be the same. Okay, that's the concept of hydrostatic. Then I will show you, I got this PR from kelas sebelah. I think this one is already discussed last week. Do you still have any question about these problems? Is anyone still got a question about these problems? Udah cukup jelas ya untuk yang bagian ini? Atau belum pada ngitung? Coba dihitung lagi ya dengan penjelasan yang kemarin. Okay, then we goes to the next problem. So by using the concept of hydrostatic pressure, you must check between these 2 points will these two must be satisfied. The depth or the height is same, and then the fluid is also the same. So for example, in this case, you have, this one is water, right? So at this point is water, and then above the water is the air. My question first, at which point that the pressure will be the same as atmospheric pressure?
A, sir.
Which point?
A.
A. Does anyone agree with Kevin? Atau ada yang tidak setuju? So at point A, the value of the absolute pressure will be the atmospheric pressure. Why? Why, Kevin?
Because it's intact with the atmosphere. It's open, sir.
Yes, correct. Because at point A, the air is open to the atmosphere. So the value will be atmospheric pressure. So in this case, the value of the pressure at point A is this one. Please consider that the unit of the pressure, this is pressure at point A, is this one. Actually, this is the unit of what? Pounds is unit of weight, right? This is the unit of area. So this is not the standard unit of pressure, because pressure should be force divided by area. Then if you have the value, the unit is the pounds over square feet, then you need to do some conversion to convert this value into standard pressure unit. How to do? You can check again the table of the conversion. You will need to use G over GC conversion. Okay, that's another problem. But from this point, for example, okay, now since pressure at A is atmospheric pressure, at point B, we have the point between, at the interface between the air and the water. Okay, but above the chamber, so we have first chamber, second chamber, and the third chamber. Above the second chamber, it's closed, but above the first chamber, it's open. Will the pressure at point B is the same as atmospheric pressure?
No, sir.
No. Why?
Because the air is not in contact with, it's not open.
Yeah, because it's the chamber is closed, so the air inside the second chamber is not in contact with outside atmospheric condition. So the pressure at point B will not be the same as atmospheric pressure. The same as point C. Okay, for example, A, B, C, D. Okay. For example, I put point A, this one point F, and then this one point Okay. At which point, or can you mention 2 points that have same hydrostatic pressure?
G and H, sir.
Sorry again?
G and H.
G and H, this one. Okay, why?
Because same medium, same height.
Yes, because it's same height. You make the baseline, for example, at the base of the chamber. Then G and H have same height, and when you travel from G to H, it's only travel in water. So the pressure at G should be the same pressure at H. How about the pressure at I? Will it be the same as G and H?
Yes, sir.
Yes, correct. Ya, karena dari G, H, I, from G, H, and G, H, and I, the pressure is, the head is the same. And all just in water. Even though at point I, it is the interface between the water and the air. Ya, jadi walaupun pada poin I itu ada di interface antara udara dengan air, ini kan semua fluidanya diam. All the fluids are in static condition, even though at point I, it is in the interface between air and water. But since the point G, H, and I got the same height, and from G, H, and I, the travel is only through water, so the pressure is the same. For example, then I put L here. How about the pressure A, pressure L, and pressure F?
A is equal to L, but not equal to F, sir.
Why?
Because F is a different medium.
Okay. So from A to L, so A, L, and F got the same height, right? You got the concept. Then A, L, and F has the same height. But if you travel from A to L, it's only travel in water. So pressure A at the same as pressure L. But from L to F, you need to go from water, then you change to air. So the pressure will be different. And this one, pressure at point L is the same as pressure at point A, and it will be atmospheric pressure. Because at point A, the pressure is atmospheric, right? Okay. Then how about B and E? Is the same head as well?
But it's in different mediums, sir.
Different medium, correct. So it should not be the same pressure. Okay, from this explanation, do you still have any question? Masih ada pertanyaan terkait cara menentukan mana tekanan dua titik yang sama dan mana yang berbeda?
Sir, can I ask a question?
Sure.
Why is pressure at A and L the same even though they're in different mediums?
No. Okay. At point A, it is in the interface between water and air. But at point L, it's completely in the water. So please remember again the concept of hydrostatic pressure. So the pressure, hydrostatic means all the fluid in the static condition, right? Then between these 2 points, it will be the same, the pressure will be the same, as long as first, the head is the same, and when you travel from one point to the other, the fluid is the same. So for example, from this one, if you travel from A to L, downward, this one, it's only travel through water, right? Then the pressure will be the same. The fact that A are in the interface, it doesn't matter. Ya, jadi walaupun A-nya itu ada di perbatasan antara udara dengan air, L-nya itu ada di dalam air semuanya, itu nggak masalah. Selama A dan L itu ketinggiannya atau kedalamannya sama. Terus kalau Anda berjalan, ya, saya tidak bisa menggunakan istilah yang lebih pas. Kalau Anda berjalan dari titik A ke titik L, itu Anda hanya melalui satu jenis fluida, itu berarti nanti dua titik tadi tekanannya sama. Jadi dua syarat itu harus terpenuhi. Satu, kedalamannya atau ketinggiannya itu sama dari suatu baseline. Jadi Anda bikin dulu baseline-nya mau di mana. Yang kedua, Anda coba jalan dari titik A ke titik L gitu ya, atau dari satu titik ke titik yang lain yang Anda bandingkan. Kalau hanya lewat satu fluida, berarti sama tekanan dua titik tadi. Ya. Kalau ketinggiannya sama, hanya lewat satu fluida, berarti tekanannya sama.
Thank you, sir.
Oke? Any other question or clarification, perhaps? Oke ya. Then how to calculate this one? Okay, so you already know that PA is atmospheric pressure. You got the value, this one. But you need to do the conversion. Then how you calculate P at pressure at point B?
Pressure A minus rho GH, in which the H is the height difference between A and B, and the rho is the rho of water.
Okay, so you make a horizontal line like this. From previous example, I have shown you that pressure A and pressure L is the same, right? So this one should be PA minus, because the point B is above the point A. So it should be lower. Then PA minus rho water G, and then height between A, B. This one. Okay, by knowing the equation, what can you comment about pressure B? Apa yang bisa Anda komentari terkait tekanan di B?
Lebih rendah dari pressure A.
Of course. Then pressure A is atmospheric, right?
Yes, sir.
So since pressure A is atmospheric pressure, and pressure B is lower than pressure A, then it means at B the condition is, masih ingat istilahnya? Tekanan yang lebih rendah daripada tekanan udara luar?
Vacuum.
Yes, a vacuum pressure. Okay, then how about how to calculate pressure at point C? First, you need to calculate pressure at this point, right? For example, you name it E. So at point E, the pressure will be PA plus density of water times G times height between A to E. And it will be the same as this one. Because from E to F, it's only travel through water. Okay, then pressure at point C will be pressure at point E. This one plus, since the position of E is below the A, but position C is above E. So this one is minus density of, when you travel here to here, the medium is, the fluid is air, right? G times H from F to C. This will be equals F. The numbers or the value, you can put it by yourself, okay? Or you can take from this one, after you get pressure at point B, for example, this is point G, right? So at point G will be at same at pressure at point B. And pressure at point C will be pressure at point G minus rho R times G times H between G to C. Kalau Anda sudah dapat nilai pressure at point B, then you do this one calculation. Should be the same. By using this calculation, and the above should be the same. Ada pertanyaan?
Sir,
Yes.
just to clarify,
Mhm.
because the unit for the 2,900 pound per square foot is not proper pressure units. To
Mhm.
convert it, do you just multiply it by G? Because isn't that what's just needed, sir?
You need to check again how to convert pounds over square feet into pound force over square feet, because the unit of force will be pound force.
I see, sir.
I
All right.
forgot the formula. You need to check the previous, the early slide, or you can check from the handbook, the conversion from pound, because pound is weight, right? But the area is already at square meters, so you need to convert pound into pound force. The unit of force in, I think it's British unit, is pound force.
But we don't have to memorize it, right?
No need to memorize.
All right, sir. Thank you.
But if you can memorize, then it's better.
I mean, okay.
Okay.
Thank you, sir.
Okay.
Pak, mau nanya lagi, Pak.
Yes, sir.
Tadi when you said like A to L is the same pressure because you can travel like you gave like an illustration in which A to L in which that you can travel in the same medium. How does that actually work? You know, so, yeah.
It's just to show you that A and L are in the same medium without any other medium. But I don't know how to explain it in the easiest way ya. Jadi untuk menunjukkan bahwa dua titik tadi itu berada dalam medium yang sama, tapi di medium tadi tidak ada fluida lain. So I show you how to check is try to travel between those 2 points. But you need to travel downward, right? Because at the top one, the chamber is closed. So if you travel downward and then upward, from A to L, it's only water. But if you travel from A to B, then it has to, from A to B, it's only water, but the depth, the height is different, right?
Yes, sir.
So,
Yes,
for
sir.
example, if you have another for example, you compare from point A to point C. So you travel to the water and then you travel in the air. So it means between A to C, there will be two different fluids. So it's just to show you that between these 2 points should not be for, in order to fulfilling the hydrostatic pressure concept, the pressure should be, the 2 points should be in the same fluid. And the same
Sir,
depth. Ya.
jadi benar nggak, sir? Kalau misalnya chamber 1 ditutup gitu, the wall sampai bawah gitu, A and B won't be the same, right?
This one is closed.
Kalau misalnya chamber 1 nih, sir, ya, the one. A and B won't be the same, right?
It's kind of difficult to justify whether it's the same or different because you cannot correlate any 2 point, right, between chamber 1 and chamber 2 because it's not connected to each other.
Okay, sir. Okay.
Yeah, it might be different.
Okay, thank you very much, sir.
Okay.
Yes, I got it, sir.
Any other question? Okay. Then I'll show you the previous one. This one, the previous exercise that we did, like when you compare this point and this point, it will only travel in water, right? But this point and this point, even though this one is in the interface, but since its travel is still in the same fluid, which is water, then the pressure is also the same. Paham ya konsepnya? Untuk menentukan apakah dua titik itu tekanannya sama atau enggak, satu dilihat dari tingginya, yang dua dilihat dari antara dua titik itu fluidanya sama atau tidak. Perkara nanti titik itu ada di interface dua fluida, nggak masalah. So, as long as these 2 points are the same fluids and the same height, then the pressure will be the same. Even if one of these 2 points are in the interface between, for example, like this one, between air and water. If you compare with this one, so it's still the same. Okay, yeah, so should be clear enough. Okay, then please remember again the concept of force balance. Force balance, if the fluid are in static condition, so the sigma of the force should be 0. So this is the control volume of the static fluid. So the fluid that we want to analyze the force balance is in the box volume. So we do not need to consider the horizontal direction of the force. So we just consider the vertical direction. And then the force that act upon this box control volume is first pressure force. The direction is downward and upward. So this one is from the upward and this one is from the downward direction. But the direction is vice versa, right? And then the second one is weight force. The direction of the weight force will be downward. This is so PZ is the pressure that act upon the area below of the box. And Pz plus delta Z is the pressure that acts upon the area above the box. Pz plus delta Z, the direction of the force is downward. We put it negative. And then the weight force is downward. It's also negative. And then Pz is upward. We note it is positive. It's up to you, but you need to be consistent. So if one direction of the force you note it as positive direction, then the others, the inverse should be in negative sign. Ya, jadi arah plus minusnya itu terserah Anda. Kalau satu arah itu sudah ditandai positif, berarti yang arahnya kebalikan ya negatif. So force should be the pressure force. Pressure times area, right? So at Z, so it means times area, which is delta X, delta Y. And Fz plus delta Z, it's Pz plus delta Z times delta X, delta Y. How about the weight force? Is mass times gravitational. Mass is the density of the fluid times volume times gravitational, or equals density delta X, delta Y, delta Z times gravitational. Nah, yang ini tandanya tadi apa? Yang ke bawah itu negatif, ini negatif, yang ini positif. So you can calculate and the sigma will be 0. Jadi Fz dikurangi Fz minus Fz plus delta Z minus weight force should be 0. Ya, yang tadi ini adalah dA-nya itu adalah delta X, delta X, delta apa tadi? Delta Y ya. Delta X, delta Y. Then the volume will be delta X, delta Y, delta Z. Then you get the value of pressure difference between the top surface and the bottom surface is equals to minus density times gravitational. For this one. What does it mean? It means the pressure of the fluid will be decreased. Minus is decreased, right? The pressure of the fluid will be decreased if the position is Z, is increased. Jadi makin ke atas, Z itu kan arahnya ke atas ya, Z plus delta Z. Nah, makin ke atas ketinggian fluida, maka tekanannya akan semakin rendah. When the head is increased, then the pressure is decreased. It will be proportional to the density and the gravitational. Okay. Now we want to use it to apply it in the real condition. Okay, for example, you have dam. Dam itu waduk. So it consists of one. So you just analyze at one side of the dinding of the wall of the dam. So at one side of the wall of the dam, you have water at one side and air at the other side. Okay? There will be two different direction of force that act upon the wall. Ya, jadi ada dua gaya yang arahnya berlawanan yang bekerja pada dinding dam tersebut. Can you mention? Gaya apa saja? So this is the wall.
Hydrostatic, sir.
Okay, both are hydrostatic, but different direction because from the left side, you have force from water. And from the left side, you have the force from air, udara. Both are hydrostatic pressure, but different direction. Okay, first we check the pressure force from the air, from udara. Is the pressure at the top part of the wall, if you compare it from the top part of the wall, the middle part, and then the bottom part of the wall, this one, is the value of the pressure is the same? The hydrostatic pressure at the top part of the wall, at the middle of the wall, and then at the bottom of the wall, from air side, dari sisi udara, tekanannya sama nggak? Tekanan hidrostatik udara di sebelah kanan gitu, yang arahnya ke kiri.
Sama, sir.
Same. Why?
Because it's in contact with the atmosphere.
Yes. Correct. Because all the point, whether it's on the top part, or in the middle part, or in the bottom, or anywhere at the side of the right side of the wall, the value of the air pressure will be atmospheric pressure. So all is the same. So F from the air will be pressure atmospheric times area of the wall. Okay, how about from the left side, the water? If is the pressure at this point, this point, this point, and this point is the same?
No, sir.
Sorry?
No. It
No.
wouldn't be the same.
Why?
Because they have different heights, I think.
Yes.
The depth of the water is different.
Sorry again. I cannot hear you clearly.
The depth of the water is different
Mm-hmm.
throughout the points. Wouldn't have the same hydrostatic pressure.
Yes, correct. And since water have a hydrostatic pressure, then the deeper the water, or at more bottom part of the wall, the hydrostatic pressure of the water will be increased. So this arrow actually representing the increase in hydrostatic pressure. Makin ke bawah, tekanan hidrostatik air makin besar. Karena tekanan hidrostatik air makin besar, tekanan ke dinding juga makin besar. Karena tekanan ke dinding ya disebabkan oleh hydrostatic pressure tadi. So the deeper the height of the water, then the hydrostatic pressure of water is increased, and then the pressure given to the wall is also increased. Then how to write those kind of force that act upon the wall from the left side, because the pressure is different, right? And the area will also be different. So how to write it? Then the F from the water, it should be this one, because F is actually P times A, but the pressure is different from point to point, and also area is larger, right, from point to point. The 0 point is this one. So like if you analyze at this point, the area will be this one. Analyze at this point, the area will be this one. and so on. So you can write F pressure force given by water to the wall will be the integration of PdA. Okay, what is the hydrostatic pressure? The hydrostatic pressure is P atmospheric plus rho G. This one. Betul nggak? Ada yang bingung nggak? So the pressure at some point, for example, at this point, will be the atmospheric pressure plus rho G dH. dH adalah interval dari titik 0 atas tadi ke ketinggian titik yang Anda lihat. So, the pressure will be the P atmospheric plus rho G dH. Okay, how about the A? A is actually if the total area of the wall, the total surface area of the wall will be W kali D ya. Kalau tingginya adalah D, lebarnya adalah W. So, this one W dikalikan D. But dA will be W. The value of W is always constant, right? Kalikan dH. So, this one should be written by P atmospheric plus
Rho GDH.
rho G. Nah, hati-hati ya. Nah, ini adalah integral P atmosferik plus P rho G dH. Oke. W dH. All are in the integration. Okay, it will be P atmospheric plus A, totalnya ya, Anda keluarkan, plus integral rho G. So you take out all the atmospheric times area, the total area times the atmospheric. Then you take the integration only for the delta P value, rho G H WDH. Dari sini ada yang bingung nggak?
Sir, DH yang dari Rho GDH pertama itu kemana, Sir?
Sebetulnya nanti itu ada perubahan notasi ya, karena kalau DH dengan DH nanti jadinya HDH gitu. Gimana nih menjelaskannya? Dulu di kalkulus diajarin nggak? Jadi kalau ada dua, if you have these two DH, not like integral DH DH, but it will be like integral H DH. Because it's the same parameters. When you combine it, it becomes like that, the notation. Tapi kenapa bisa dipecah why it can be, this is only the air, right? Why can be this one, from this one? So it means the pressure force given by water consists of the atmospheric force times total area plus the delta of hydrostatic force time area. But the delta of the hydrostatic force is like in different segment, right? Like at the first, it's on very small and the area is small. And at the bottom, the hydrostatic force is higher and the area is also higher. So you can take out the atmospheric pressure times A plus integral rho G H VDH, VDH. Rho GH VDH.
Kalau yang PATM times A mah gara-gara A-nya constant ya, sir. Because PATM is just only yang waktu paling atas itu kan ya, sir.
Okay, maybe I'll show you some more explanation. For this one, okay. At this point, the pressure at the wall at 0 will be P at the M times area only. Areanya kecil sekali. Okay. At this point, let's say it's point 2. At point F at point 2 will be P2 times area. The area is this one. Just the first delta H times V. And P2 is P atmospheric, right? Plus rho G delta H1. This is delta H1. Area is delta H1 times V. Dari sini paham ya? Tekanan di titik 2, gaya di titik 2 itu adalah tekanan di titik 2 kali area dari atas sampai titik 2 saja. Tekanan di titik 2 itu apa? Tekanan atmosferik ditambah rho GH sampai titik 2. Delta H1 itu H dari atas sampai titik 2. Luasnya apa? Luasnya ya hanya yang diarsir saja. Delta H 1 kali W. How about pressure at point 3? The same. F at point 3 will be P atmospheric times rho G delta H from point 0 to point 3 times delta H V. So the area is bigger. Sampai bawah, areanya adalah area totalnya. Seperti itu. So this one, actually you can separate the value of the water by take out the pressure atmospheric times A, and then you just take you just calculate the integration of the area and the integration of the pressure. Ada yang masih bingung?
I'm okay sih, sir.
Others? Ya, kenapa bisa muncul dua suku ini ya? Kenapa tahu-tahu PATM-nya keluar gitu, dikalikan dengan A? Karena tadi untuk menghitung tekanan hidrostatik di setiap titik itu adalah PATM ditambah rho GH di titik itu. PATM kan selalu sama ya, di berapa titik pun PATM-nya selalu sama. Kemudian sampai yang titik terbawah, luasnya berarti yang luas semuanya. Nah, sehingga ini dikeluarkan. Sehingga Anda tinggal menghitung rho GH hidrostatik yang berubah terhadap luas yang berubah, dikali luas yang berubah. The meaning of this equation is that one. This is the delta of the hydrostatic pressure. because the lower the position, the hydrostatic pressure is higher, then the area is also higher. Okay? So basically, the integration becomes, dulu ya, biar bisa nulis. The integration becomes F water is P ATM times A plus integral rho G H WDH, or this one is equals integral this one becomes, you take out the parameters that got the constant value, right? It will be, this one is the same as rho G V W integral this one. This is the value of the pressure force caused by the water. And then the value of the pressure force caused by the air is this one. And delta F should be F water minus F air. So you can take out this one. Same, right? And the value of the sigma F will be this one. Karena yang PATM kali A-nya saling menyediakan. From the air, you got atmospheric pressure times area of the wall, and from the water pressure, the force from the water, you get the atmospheric pressure times the area. Then it's cancel out. Then you only have this one.
Sir, F total is the amount of pressure that the wall have to withstand, yes, sir.
The sigma of the force, the pressure force that the experience by the wall. Jadi,
Okay.
no ya, karena why the sigma F is not zero, even though the wall is in the standstill position. Harusnya kalau if the wall is in the, because the wall is not moving, right? So the sigma F should be zero. But in this equation, why the sigma F is not zero?
Because belum dikurangin the amount of force that the wall exert to the water nggak sih, sir?
The amount of what?
Like the force that the wall exerts itu belum ditambahin belum sih, sir? Because kayak that's what we have to find, right?
Okay, but that value should be the same as this one. But actually, the wall has weight force, right? That we do not consider in this equation. So basically, the F total mentioned in this equation is only the differences of the force acting or the force that experienced by the wall that caused by the water and the air. Jadi di sini F total ini adalah gaya yang diterima oleh dinding yang hanya disebabkan oleh tekanan air dan tekanan udara saja. Belum mempertimbangkan semua gaya. Kan ada gaya berat ya, ada gaya berat, ada gaya tekanan udara dari atas gitu. We do not consider that equation, that force in this equation, but we just see the sigma force from the side of the wall. Okay, so just integrate this equation, then you get the integral HDH apa? Setengah H kuadrat ya. Betul nggak?
Betul, sir.
Relation of h dh should be half of h quadrat, then from 0 to d. Then you have the f total is this one. Okay. Any question first? Okay. Actually, there is a simpler way to calculate if you know the titik berat or the weight point of the area of the wall. So remember again, force will be P times A, right? And pressure will be rho G H times A. But in calculating F total, for example, you have this is area of the wall, ini D, ini W. Titik berat itu apa ya bahasa Inggrisnya ya? Weight point?
Center of mass, sir.
Yeah, center of mass at which point? If you have rectangular with the width of weight W and the height is D, then the center of mass will be this one, right?
In the middle, sir.
Yeah. This one is half D. If you take the 0 point is from the top part, so it should be rho G T times D. So the area is the area of the half, this one, based on at which point the center of the mass is placed. Ya, tinggi keseluruhannya kan D, betul ya? A-nya ngitungnya gimana? A-nya bukan semua A, tapi hanya A pada titik di titik beratnya. Dihitung dari atas ya. Titik nolnya kan tadi ada di atas. Jadi kalau titik beratnya ada di setengah D, berarti A-nya adalah setengah D kali W. So it should be rho G D kuadrat W times 0.5.
Kok bisa pakai itu, sir? Center of mass.
Karena tadi the concept is this is only the F total, right? F total is the sigma F between the air and the water. So actually the F total, the sigma F, is the hydrostatic pressure, ya. Tadi ya, tekanan hidrostatik yang nilainya beragam, sehingga Anda perlu menghitung berapa nilai tekanan hidrostatik rata-rata. Menghitung tekanan hidrostatik rata-rata, berarti Anda perlu menentukan berapa ketinggian rata-ratanya. Ketinggian rata-rata bukan setengah dari tinggi, tapi dari titik di mana titik berat bidang luasan yang Anda cari itu berada. Gimana ngomongnya? So the sigma F, the F total is actually sigma F, is the hydrostatic pressure, the average of the hydrostatic pressure times the average of the area. It means you can calculate the average hydrostatic pressure by calculating the total hydrostatic pressure, rho G. H total berarti D ya. This is the total hydrostatic pressure times the area, but the area is only the average area. Average area is the area where you calculate if you find out the center of the mass. Is at the point where the center of the mass is placed. Ya, jadi di situ Anda akan mendapatkan luasan rata-rata. Paham nggak kira-kira?
Oke, sir.
Kira-kira seperti itu ya. Cara nyarinya ya tadi, karena sebetulnya when you calculate by using the integration, actually you find you want to find out at which point from the top one that you have the average value of the pressure.
Jadi sir, kayak gimana ya? Kayak seandainya all that force is pushing at that point ya sir.
Ya,
Oke.
bisa membayangkan nggak?
Bisa sih sir.
Jadi pada luasan yang pada bidang titik berat tadi, itu tekanannya adalah ya rata-ratanya gitu. Kan Anda tadi mau menghitung tekanan rata-rata kan. Gaya rata-rata dengan menghitung tekanan rata-rata. Oke. Do you have other class after this?
Ada jam 3 sir.
Okay, I think we can stop the discussion for now. But I want to ask something first.